Okay, so now we're going to look at graphing some examples and identifying some key pieces of information for each function here. So I had mentioned that when you guys are graphing these, the domain is always going to be negative to positive infinity. So for number 1, y equals 2 to the x minus 3, right away, you can just put the domain as negative to positive infinity. Remember, domain is from that left to right direction, but it's always going to be continuous. So you don't even need to think about it. You can just always put negative to positive infinity for the domain of these. Now, the horizontal asymptote is always going to be the value at the end of your equation. So 2 to the x minus 3, the horizontal asymptote is going to be at negative 3. So you can even draw that in, and I kind of like to draw it in because as you graph it then, you sort of know that your graph shouldn't really be passing that line because it's just going to come down and sort of get closer and closer and closer to it, but not really approaching it. So I always put that dotted line there just to kind of show where my graph should be ending, if you will. All right, so we're going to, let's do, I don't know why those values are not in there. Let's do 0, 1, 2, and 3, but we're going to actually graph it. So if you do have a graphing calculator, remember how we graph anything. You're going to go to the y equals, clear out anything that might be in there, and then you just type it in. So 2, your caret to the power of x, and put that exponent in parentheses, minus 3. So you could graph it. It should look like one of those pictures on the front page there. It does. And then if you're trying to get the table, you need to do second graph. Okay, if you don't have a graphing calculator, we're going to head to Desmos. And we're going to do y equals 2 to the x minus 3. Okay, so we have a general picture there. We can zoom in a little bit here. So it wants us to fill out the table for 0, 1, 2, and 3. So at 0, you have negative 2. So 0, negative 2. At 1, negative 1. I'm just going to go back and write those down. Negative 2 and 1. And then you want to look at 2 and 3. So at 2, so go over to the x value, go up to 1. And then at the x value 3, 1, 2, 3. X value of 5, so 3, 5, 2, 1. And then we will plot those. So let's go ahead and plot those guys, and then we'll fill out the rest of that information. So 0, negative 2, 1, 1. I think that's supposed to be a negative 1. 2, 1. And 3, 1, 2, 3, 4, 5. Now, this is not linear. This is not a straight line. It's curved. And it comes down then, and hopefully you guys can draw yours a little bit better. And then comes down right along that horizontal asymptote. So it shouldn't come down and like go past your asymptote. It's coming down and starting to level off at your asymptote. So the other two things it asks for is the range and the y-intercept. So just remember, the y-intercept is whenever x is 0. So either go to the graph and find it. You can look on your graph since you plotted it. We actually found it on the table, but the y-intercept is going to be 0, negative 2. Now the range. If you remember, the range is from bottom to top. So the lowest point your graph is at that horizontal asymptote, and then it goes up from there. So the lowest point your graph is at that -3 value. So your graph is from -3 and up. Everything is from -3 and up. There's nothing below -3. That is the lowest place your graph is. And since it's up, it's going to positive infinity. So infinities always get parentheses. And -3 is an asymptote. There's no point at -3 or on -3. It's an asymptote, which just means you just keep getting closer and closer. So the range is going to be from -3 to positive infinity. So let's go ahead and see if we can do one the whole way through, maybe a little quicker to get a hang of it. So let's go down and look at number 2. So the domain, doesn't even matter what your function is, it's going to be negative to positive infinity. What's the horizontal asymptote? Well, this is the number at the end of your exponent, but it's not the number at the end of your equation. If there is no number at the end, like the -3 in the first problem, then it's just 0. So that will be your horizontal asymptote. You can graph that in there if you want. Sort of a visual. And then let's go ahead and graph this guy. So 2 to the power of x plus 1. So I'm going to go to Desmos. 2 to the power, we got to put that exponent in parentheses. I'm going to get rid of the -3. So 2 to the power of x plus 1. And then we'll graph it. So we're asked to find -1, 0, and then we'll do 1, 2. We'll just do them in order. So -1, go up here, is +1. 0, 2, that's going to be your y-intercept. And then 1, maybe 1, 4. And then we might have to go up a little bit. And then x2 is at 8, 2, 8. So we can go to our table then and fill those values out. So -1, 1, 0, 2, and then we can plot it. 1, 4, 2, 8. So that's going to be your y-intercept, and we're going to write it as an ordered pair, and we will plot these other points. So -1, 1, 0, 2, 1, 4, 2, 8. Right at the top there. And then we'll draw it. And remember, it's not linear. It's not a straight line. It's a curve. Try to connect your dots. I'm not doing so well here. So what will your range be? The lowest point that graph is going is 0. So the horizontal asymptote and the range always correspond with each other. The range should always include the horizontal asymptote in it. So 0 to positive infinity. Everything gets parentheses. No brackets for the domain and range in these guys.